Hello everyone. So in this lecture, we will discuss different concepts and techniques for data mining. So before going for data mining, we need to do one important step, that is data pre-processing. We need to pre-process the data. So why we need to pre-process the data means to improve quality of data. So if we are unable to improve, or if we are not analyzing the quality to data, it will not give the result, or it will not give the correct results, or we can say it will give erroneous results which are not useful for further processing. So that what we have to do is, before analyzing any data, we have to pre-process the data to improve data quality. And also in this lecture we will discuss what are the major tasks in data pre-processing, like data cleaning, data integration, data reduction, and data transformation and discretization techniques that we will discuss in this lecture. So why we need to process the data? So we need to process the data for accuracy, for completeness, for consistency, for timeliness, and for believability, and for interpretability. So we need to process the data for accuracy, means whether the data is correct or not, that we have to analyze before going to uh, analyze the data. Completeness means whether we recorded all the fields or not, whether we recorded all the available fields or not. Consistency means some modified but not some are not, and dangling, etc., leads to inconsistency, means we need to take care of the consistent databases. Timeliness means we need to update the data on time. This is especially required when we are analyzing time series data or transactional data. And believability means can we trust the data or not. When we will trust the data means if the data is correct, then we will trust the data. Otherwise, we will not believe the data, or it is not a trustable data. And interpretability means how easily the data can be understood. So these are the different tasks in data pre-processing, that is data cleaning, data integration, data reduction, data transformation, and data discretization. Data cleaning means we will perform different tasks to clean the data. For example, we will fill the missing values, smooth noisy data, identify or remove outliers, and resolve inconsistencies. So filling, for example, filling missing values means for a particular database, there may be 5 fields required. For example, name, age, address, price, or any other field. When we are filling the data, suppose age is intentionally not filled or address is intentionally not filled, then that leads to a missing value. We need to handle those kind of missing values. So how we will handle those missing values, that we will discuss in the later parts. So these are all different things that we have to take care in data cleaning process. After that, we need to integrate the data. So we have data from multiple sources, maybe web, maybe some databases, some transactional databases, or some census data. So the census which we will give continuous data. So all these different databases need to be integrated before going further. After that, we need to perform data reduction. In data reduction, we have different steps, that is dimensional reduction, numerosity reduction, data compression, etc. We will discuss in the further classes what is dimensionality reduction, what is numerosity reduction, and what is data compression, etc., in a detailed manner. After performing data reduction, we have to go for data transformation, data discretization. So in this we will use different techniques like normalization, concept hierarchy generation, etc. Normalization means it is not the normalization what you are thinking in DBMS systems, but normalization means here the normalization is fitting the data in a particular scale, means fitting any kind of data before 0 to 1, for example, or fitting any kind of data between 1 to 10, or fitting any kind of data between some levels. So this is called normalization in data mining. This is somewhat different from your DBMS normalization. After that, we concept hierarchy generation means based on the data we will generate some concept hierarchies, like suppose street comes under village, village comes under mandal, maybe mandal comes under district, district comes under state, state comes under country. Like that we have to gather some kind of concept hierarchies. So these are the major steps in data preprocessing. So these are nothing but which we are discussed in the previous slide. So this is the data. Before cleaning, the data may be like this, means several inconsistencies or several noises or several misinformed data is there. After cleaning we will get the good data. So in the data integration step, what we will do is we will integrate different kinds of data sources into a single database or single data mine. So this may be a database, this may be a web data, or this may be flat files. We are integrating all these into a single database. So in data reduction, what we will do is we will reduce some dimensions. For example, observe this one. Here we have A1 to A126. Like that we have transaction 1 to transaction 2000. After that, what we did is we reduced some dimensions from this one. So now we have A1 to A115. We reduced some attributes, like that. From T1 to T1456 means we reduced some transactions or some records. So like that we will reduce the data before analyzing this data. So what is data cleaning? That we will discuss. So the data cleaning is nothing but in real world the data is dirty. Dirty means it may have several inconsistencies, several unwanted data, or some missing data. So many problems may be there in real world data. So we can say that the real world data is dirty. So the reasons are lots of potential incorrect data, instrument fault, human or computer error, transmission error, like that. So many reasons we may consider. So the data may be incomplete, means lack of attribute values, lacking certain attributes of interest, or containing only aggregate data. For example, occupation is not there, means occupation attribute is not recorded. So for this what we have to do? Like that we have some noisy data, for example containing noise, errors or outliers. For salary, the salary field contains -10. It is not correct information. -10 is not the salary. So salary should be in some positive number. There should not be a minus number. So it is an error. So what we have to do for this type of data, that we will see. Next we have inconsistent data, means for example containing discrepancies in quotes or names. Example, age is 42, birthday is 3/7/2010. If he born in 2010, how his age becomes 42? So means this is inconsistent data. Data is not correct. For example, rating 1, 2, 3 in some area, and in some databases the rating may be ABC. So this causes inconsistent data or discrepancy between duplicate records. So same records existed at multiple sources. So these are all comes under inconsistent data. We have to avoid this kind of data. Next, intentionally, we may insert some false data, false or wrong data. For example, in the birthday field, we simply entered January 1st for every record in the database. This is intentionally we are creating mistakes. So before processing the data, we need to do pre-processing steps in that. In data cleaning step, we have to perform or we have to clean all these kind of inconsistent data like incomplete data, noisy data, inconsistent and intentional data. So incomplete or missing data. So data is not always available. Example, many tables have no recorded values. Intentionally, what we will do is we will not enter fields in the all the fields in the records. For example, when we fill some kind of applications or some forms in the web pages, what we will do is intentionally we will not fill optional fields. So that may create problems when we want to analyze the data. So missing data may be due to equipment malfunction. There may be equipment is not working, inconsistent with other recorded data and thus deleted. Data not entered due to misunderstanding. Said data may not be considered important at the time of entry. So not register history or changes of the data. Missing data may need to be inferred. So these are all different causes for incomplete or missing data. So how to handle this missing data? So we have different techniques to ignore or handle this kind of missing data. One of the technique is ignoring the tuples. Usually we will ignore the tuples when class labels are missing. So actually this is not effective if the data is more. And another technique is fill the missing values manually. If the values are missing, we may fill those values manually, but it takes a lot of time, or it may lead to some confusions, or it is tedious and infeasible approach also. Or we will fill the missing data with automatic values, or we can say a global constant. For example, we may fill with a value like unknown, none, 0. So all these things may lead some kind of confusion, but we have to handle this missing data by these ways. And we may fill with the attribute means. For example, we will calculate the mean for that particular values, and we will fill this mean value in the entire databases. The attribute mean for all sample belonging to the same class. And the most probable inference based, such as Bayesian formula or decision set, that we will discuss. So how to handle noisy data? So we will handle noisy data in different ways like binning, regression, clustering, combined computer and human introspection. So in binning, what we will do is we will sort the data and partition into equal parts. The part is called as bin here. Then then we can smooth by bin means, or smooth by bin median, or smooth by bin boundaries. So that we will see in the next slide. Or we will use regression, smooth by fitting the data into regression functions, or we will do clustering, or we will combine computer and human inspection. Like we will check the data manually, and we will try to avoid that noisy data. So this is what the binning method looks like, or this is we can say this is a binning method. So we have some data in terms of dollars, that is 4, 8, 9 up to 34. We have different values. So in binning, what we will do is we will divide this data into equal bins. For example, in bin 1 we have 4 at 9, 15. In bin 2 we have 21, 21, 24, 25. In bin 3 we have 26, 28, 29, 34. So in this way what we did is we partitioned into equal parts. After that we will smooth these bins by bin means. Bin means means what? For bin 1 if we calculate the mean we will get 9. So for every value we will replace with the bin mean value. So bin 1 becomes 999. Like that for bin 2 if we calculate mean we will get 23. What we are doing is we are substituting this mean value in to replace every value. Like that in bin 3 what we are doing, we are replacing every value with bin means. Next we will smooth by bin boundaries. So this is also one technique. Means we will see the boundaries of every bins. For example, in the bin 1 we have 4 as lower boundary and 15 as upper boundary. What we will do is we will replace 8, 9 all remaining values based on these boundaries. So in bin 1 we have lower bound 4. 8 is actually 8 has actually short distance than 15. So if we add 4 for the lower boundary we will get 8. But to get 15 we have to add 7. So 4 is smaller. So what we will do is we will replace the value 8 with 4. Like that, to get 9 from the lower bound we have to add 5. To get 15 from the upper bound we have to add 6. So as 5 is smaller than 6, what we will do is we will replace 9 with 4. So like that we will smooth the values by bin boundaries. In the bin 2 we will replace the values like this: 21, 21, 25 and 25. In the bin 3, 26, 26, 26, 34. Like this we will use binning method to handle or to use some smooth data. Like that we have some outliers. So how outliers will be handled means based on the objects what we will do is we will form some clusters, and the object which doesn't belongs to any cluster is an outlier. We will neglect these outliers, or we will omit these outliers. So actually this outlier analysis is mainly used in analyzing fraud detection. Next, so we need to clean the data discrepancies may be more, so we need to detect those data discrepancies, and after detecting those data discrepancies we need to use metadata, we need to check field overloading, we need to check uniqueness rules, consecutive rules, etc. Use some commercial tools like data scrubbing and data editing to avoid data discrepancies. And we may use data migration and integration tools like ETL, iterative and interactive plotters wheels, etc. to clean the data. So after cleaning the data we have to integrate the data. So data integration means combining data from multiple sources. So for example, take a.customer id equals to b.customer hash. So in one database the customer id attribute is like this, in another database the customer id attribute is like this. When we are integrating these two databases we may have inconsistencies in the attribute names, because here it is id but here it is not id, it is a hash symbol. So we need to eliminate, or we need to smoothen these kinds of incompatible fields. So integrate metadata from different sources. We have entity identification problem like this: identify real world entities from multiple sources. Example, Bill Clinton In one database it is written as Bill Clinton, in another database it is written as William Clinton. So we need to identify the real world entities, and after that we need to detect and resolve data value conflicts. For same real world entity or attribute values from different sources, there may be different. So the possible reasons are different representations like this. For example, here it is represented like this. So different representations, different scales, or different metrics, like somebody measure the weight in kilos, or somebody may measure the weight in pounds, or some other units. So these are the different discrepancies that we have to avoid, or that we have to solve when we are going for data integration. So handling redundancy in data integration means, so redundant data occur when we integrate multiple databases. We need to identify objects. The same attribute or object may have different names in different databases. One attribute may be derived attribute and from other attribute from another table. Like that, we need to identify this kind of data. And redundant attributes may be able to be detected by correlation analysis and covariance analysis. Careful integration of data from multiple sources may help to reduce or avoid redundancies and inconsistencies, and to improve mining speed and quality. So for that we will use different kinds of techniques. We will use on different kinds of data. In data mining we have different kinds of data, like nominal data, ordinal data, coordinate data. For different data we will use the different techniques to avoid this kind of mismatches. So one of the technique is chi-square techniques, which is explained in this slide that you can see. So this is chi-square calculation. This is an example how we were eliminating some inconsistencies when we are integrating data from multiple sources. Like that, we have correlation coefficient to avoid that. So we will visually analyze the correlation coefficient. What we will do is we will scatter plot, and we will fit the data into some normalized form, like -1 to 1 or 0 to 1 or 1.0 to 0.1 to 1.0, and we will correlate by means and medians. So we will use covariance on numeric data. So please observe the slide that you will understand what we are doing. These are the different techniques. There is nothing much to explain every technique. You can use some techniques to get inconsistencies vanished. So, so example covariance, and after integrating we need to reduce the data. So this is data reduction steps. So data reduction means we will obtain a reduced representation of data set that is much smaller in volume, but it produces the same result. Means out of huge data we will pick some sample data, that is reduced data. Why we need to reduce means, a database or data warehouse may store terabytes of data. We will not, in real time, we will not analyze this much of data. So to analyze this much of data, we require huge computational power, and huge hardware is required. But complex data analysis may take, it is also take long time to run and complete data set. To avoid these kind of things, what we will do is we will select some sample part from existing data by applying data reduction technologies, and we will analyze that sample data by using data mining techniques, and we will get the desired results. So we have different data reduction strategies like dimensionality reduction, numerosity reduction, data compression. So dimensionality reduction means we will reduce the dimensions of the data of interest. Means we will remove unimportant attributes, only we will consider important attributes. For this we have different techniques are available, like Waverly transforms, principal component analysis, feature subset selection, features criterion, etc. Like next, we have also numerosity reduction techniques, regression and log linear models, histograms, clustering, sampling, data cube aggregation, etc. And so we have some data compression techniques. So all these are different techniques to reduce the dimensionality reduction. We have different techniques that are explained in these slides. So please go through this, pause the video and go through these slides, you will understand. So for numerosity reduction, we have parametric and non-parametric methods. Parametric data reduction, we will use regression and log linear methods, linear regression, multiple regression, log linear model. We have different regression analyses. We have some histograms, and we have some methods to reduce redundancy of data. We have clustering, means partitioning data into different kinds of clusters based on similarity, and we store cluster representation. Example, centroid and diameter can be very effective if data is clustered but not the data is smeared. Can have hierarchical clustering and be stored in multiple multi-dimensional index entries. Means all these points represents how we will cluster. Actually, clustering I discussed in the previous slide. So sampling, different type of sampling methods. We have two types of sampling methods, like sampling with replacement, sampling without replacements. The upper part of this diagram represents sampling, sample random, simple random sample without replacement. This one, a simple random sample with replacement. These are the various techniques. So this is raw data, and this data is clustered into a sample data. So data cubes, how we will reduce the data. This slide represents how we will compress the data. We have two types of compression techniques, like lossless compression and lossy compression. Lossless compression means after compression, when we have original data, then this is lossless compression. If we lose or if we are going to approximate the original data, then it is the lossy compression data. After data reduction techniques, we have data transformation and data discretization. Data transformation means it is a function that maps the entire set of values of a given attribute to a new set of replacement values. We have different methods for data transformation, like smoothing, aggregation, normalization, and discretization. Smoothing means we will remove noise from the data, and attribute or feature construction, we will add new attributes if required. And in aggregation, what we will do is we will summarize the data, or we will generate data cubes by we will construct data cubes, or and we have normalization, means we will scale the entire data in a specified range. For example, we have different techniques to normalize data, like min-max normalization, z-score normalization, and normalization by decimal scaling. We will discuss all these techniques. We have all these techniques. We will discuss one by one in the later parts. And we have discretization, means we will generate concept hierarchy by using that data. So these are the various normalization techniques: min-max normalization, z-score normalization, and normalization by decimal means. For example, in min-max normalization, consider an example. The income range is $12,000 to $98,000. So what we have to do is we have to normalize this thing into in the scale of 0.0 to 1.0. Suppose somebody has $73,000 as an income, we have to normalize between the scale. So to normalize, what we are doing, we are using some kind of formula, and we are fitting this value, 73,000 value, into 0.716. So like that we will perform some kind of normalizations to normalize the data in data transformation steps. Like that we have different techniques available that you can see. After that, discretization. So actually in data mining we have three types of attributes, like nominal attributes, ordinal attributes, and numeric attributes. For example, for nominal attributes are color, profession, etc. These are nominal attributes. Ordinal attribute means values from an ordered set, example military or academic rank. Numeric values means real numbers, example integers or real numbers. So we have discretization means we divide the range of continuous attributes into certain intervals. We will discretize the values. Interval labels can be used to replace actual data values. They may reduce the size of discretization. We have supervised and unsupervised discretization. The main thing in discretization is we will discretize, or we will divide based on some aspects. So we have different data discretization methods. Some of them we discussed in the previous slides, like binning, histograms, clustering, decision tree analysis, correlation analysis. All these are discussed in the previous slides. So in this slide, they explained how the binning will be performed. Already we see what is binning and how we will perform binning. So next, the concept hierarchy generation means based on data we will generate some concept hierarchies. The concept hierarchy is organization concept hierarchical, and it is usually associated with each dimension in a data warehouse. These hierarchies facilitate drilling and rolling the data warehouses in multiple granularity. What is drilling down and rolling up, that we will see in the later parts. The concept hierarchy means we will discretize the entire range of values into different hierarchies. For example, consider age. We have different numbers for age, like 1, 2, 3 up to 100, maybe different numbers are there. For this field, what we will do is we will convert this field as a concept hierarchy. Like suppose if he is below 20 or below 25, he is youth. After 25 to 50, he may be adult. After 60 50, he may be senior. Like that, what we are doing is we are generating concept hierarchy based on the values of a particular fields. So concept hierarchies can be explicitly specified by domain experts or data warehouse designers. So concept hierarchies can be automatically found for both numeric and nominal data. For numeric data, we will use discretization methods. So these are all different discretization methods. This is nothing but the example of a concept hierarchy. For example, street, city, state, and country. Okay, this depicts concept hierarchy. So with this, the data processing concept is completed. In data processing, what we mainly discussed means what is data quality, how to achieve this data quality by using different techniques, and data cleaning, data integration, data reduction, and data transformation, and data discretizations. So in this lecture, I will stop this lecture for now, and we will continue in the next unit. Thank you.